Hi guys, welcome to Piece of Code and welcome to this video. So in this video we're going to see adapter design pattern. So this is the second video in this design pattern series that we started I think a week back, and in the previous video we had discussed what are the different types of design patterns and how it is important from an interview perspective and also from an architectural perspective. So this is one of the low level design patterns, which is adapter design pattern. So what is an adapter design pattern? First of all, what kind of design pattern it is? We saw three types of design patterns, right? One is a structural design pattern, one is a creational design pattern, and another one is behavioral design pattern. And we discussed like what is the advantage and what is the need of each type of design pattern. Now this adapter design pattern comes under structural design pattern. And if you remember, what we discussed about structural design pattern is that it is used to work with incompatible classes or incompatible objects. Now to understand adapter design pattern, what incompatibility it resolves, let's take a very basic example of a socket or an adapter. So you have your mobile charging adapter and you have a socket, right? Now this is your phone, this is a mobile phone. Now for your phone to get charged, you cannot directly take your phone and insert it into the socket, right? You need some kind of medium to connect your socket to your mobile so that the power flows in from the socket to your mobile and your mobile gets charged. And what we use is known as an adapter. I mean your charger, but it has an adapter. So this adapter, which actually inserts into the socket, and then using a cable you connect it to your mobile phone. Simple thing. So this is a very basic real life example of how the adapter design pattern works, right? Just basically there are two incompatible types over here because mobile is a separate thing and socket is a separate thing. So you need to work with each other, right? And then you introduce something known as an adapter. Okay. Now in the adapter design pattern, there are three things that you need to understand. Then you don't need to mug up the code or anything. You will be able to write the code like in a blink of an eye. The first thing is the client, right? Let's list down everything and then try to understand what each part of what each thing means over here. First thing is the client. Second thing is the adaptee, okay, adaptee, and the third thing is the adapter. Obviously it's an adapter design pattern, so we'll obviously have an adapter, right? Now in this example you can now figure out what each thing means. At least you will figure out who is the client over here in this particular design pattern. Obviously in this case the mobile is the client, right? And you can also figure out what is the adapter. Basically this is your adapter, and obviously there is one left, so basically a socket is the adaptee. Okay, so the client is someone who wants to work with something. For example, a mobile needs to get charged, it wants something from the adaptee, but due to their incompatible nature they are not able to communicate with each other. So in that case your adapter comes into the picture, right? Pretty simple. Let's take another example, right? So basically there is some European guy, maybe he's from Italy, right? And then there is this Japanese guy. Now the European guy, who is the Italian guy, let's make it Italy, so Italian guy wants to communicate with the Japanese guy, but they don't know each other's languages. So in this case the European guy wants to communicate with the Japanese guy, so the European guy is the client. Now what the Japanese guy does is that it introduces a translator in between them, a guy who translates the language between them. So this can be your adaptee, and basically the translator will be your adapter. Okay, makes sense. So this is also another example of real life example of where you can use adapter design pattern. You can figure out a lot of examples on your own. Okay, now let us talk about now this was the theory about adapter design pattern, guys. Let us talk about let's try to do a code, and before doing the code, let us see the UML diagram, or if you don't understand UML diagram, just a diagram before we actually write the code. I always say whenever you actually write the code, before that you just create a diagram or something like that, right? So what we need over here, we need three things, right? One is the client, another one is the adapter, and third one is the adaptee, I would say. So let's first create the client, right? This is your client. So this can be a class, right? This is your client, and then we need an adapter. Now when you are talking about the adapter, guys, you first create an adapter interface, and then a concrete class is implemented from it, right? So what I mean is, first of all, you will have a adapter interface, you have an adapter interface, and from there a concrete class gets implemented. So this is a concrete adapter. So concrete is nothing but a whole class. Now this is also a concrete. This can be, this depends on you. The client depends on you. You can have a interface, okay, and then the client is deriving the is implementing the interface. I mean, it's up to you how you design your classes. But when it comes to the adapter, this is the thing that we go with, because there can be multiple adapters, right? So you will have one adapter interface over here, and the multiple adapters can implement that particular adapter. But when it comes to client and adaptee, you are free to do whatever you want. Okay, so first we have the client, and then we have the adapter. This is the adapter interface, and then we have the concrete adapter, which is a class which implements the particular adapter interface. And then we have the adaptee. This can also be a class, or you can keep an interface over here, and then the concrete adaptee. Your adaptee can be a class implementing from the adaptee interface. Depends on you, but just to keep it simple, this is a very basic diagram where we have the client class, and then we have the adaptee class, and then we have the adapter interface and the concrete adapter over here. That's it. Very basic diagram. If someone asks in the interview also, you can go with this. It's a very easy to understand. Now you can ask me, okay, now you have the client, okay, client will use the adapter, somehow it will use the adapter to communicate with the adaptee. Now how will this work, right? Is there any relationship between the adapter and the adaptee? Because obviously there should be, right? Because otherwise how will you use it? Correct? So we were talking about like what can be the relationship between this adapter and the adaptee, right? So this client will use the adapter to get something from the adaptee, right? So in this case there will be has a relationship between the adapter and the adaptee. So the adapter has a adaptee. Now when we see an example, this will become clear, because there cannot be a relationship between the adapter and the adaptee, then the whole equation changes, and this doesn't stay as an adapter design pattern, it changes to something else itself. Now as I said, feel free to add more interfaces above and to your adaptee and to your client, whatever you want, and that is up to you. But the main thing that we need to discuss over here is the adapter design pattern, which is the adapter interface, and then we have a concrete adapter, right? I hope that is making sense. Now let us take the example and let's try to write some code based on this particular thing. So as I told you, The two things here, let's take one example over here. Let's take the example of this particular thing where we have a European guy, and then we need a translator in between, and then there is this Japanese guy, which is the adaptee over here. All right, so this is our client, and this is the adaptee, and this is the adapter. Let's go and write some code right now, and then you'll be able to understand what I really mean by that. Okay, let's open up our IntelliJ. You can use any editor of your choice, but IntelliJ is kind of my recent favorite, so I'm going to use that. So over here in the src folder, I'm going to create a new package, and I'm going to name it as adapter. Okay, I think the adapter spelling is ADAPTAR or ER. Well, whatever it is, I think it is AR. It's ER. Okay, so adapter DP or adapter design pattern, right? So in this case, what we're gonna do over here is we're gonna create a new package over here, and we're going to name it as client, so that there will be very good logical separation between the three things. So we have the client over here, and then we want to create another package, and we're going to name it as not inside the client but outside the client, and we're going to name it as adapter, right? And then we're going to name it, create another class, and we're going to name it as adaptee, right? Great. So just by looking at the example, guys, we have this thing that we need to do. So the translator will be the thing. So the client is European, right? So for the client, I'm going to create a new class. I'm going to name it as main, where we will execute the adapter so that it will translate my language in Europe to your particular Japanese, right? Okay, so I'm going to Italian to Japanese, my bad. Inside here, I'm going to create a main method over here, and that should be fine. We're going to use it later. And then inside the adaptee, I'm going to create a new Java class. It's going to be very simple, and I'm going to name it as Japanese guy, right? So inside this Japanese guy method, I'm going to create one method which is void. Let's keep it public. So public void speak Japanese, right? And here what I'm going to say, I'm going to say s out, because I have a little bit more experience in Eclipse, so I always write sys out, but here it is s out. So here I'm going to just say arigato, which is basically thanks in Japanese. So this is a very simple thing. I mean, I'm writing in English, obviously. Just think of it as in Japanese, right? Speak Japanese we have over here. All right, so what we're gonna do is we're gonna go inside our adapter. Now this is our adaptee, right? And it is very simple. We have a class name as Japanese guy, and it speak Japanese. That's it. Then we're gonna go inside our adapter package, and we're gonna create a new class, and we're going to name it as translator, right? We're gonna name it as translator. This is going to be an interface, right? Very simple. So this will be our adapter interface. I hope that is making sense, guys. Okay, now what we're gonna do is we're gonna go over here, and we're gonna create a new Java class, and I'm gonna name this class as European translator or Italian translator, whatever. Italian translator, and this will be a class, and it will implement the translator interface, which is basically our adapter interface. Now this is the concrete class that I was talking about. If you go over here, this is the concrete class of your adapter. Now here, as I told, like, now just try to understand how are you going to use this Italian translator? Now the client, which is the Italian guy, he will try to use the translator to translate into Japanese. Now you can say, okay, what I will do is I will have a method over here. I will say public void translate to Italian, sorry, not Japanese. And here as out, I don't know what is hello in Italian, so I'm just gonna say hello, right? So just assume that the translation of arigato to Italian is hello. I'm sorry, I don't know what is hello in Italian, so pardon. Now if I go over here, okay, now I'm not going to use this, otherwise it will be a little bit problematic. So I'm not going to do anything inside this translate to Italian method, but instead what I'm going to do is I'm going to say Italian translator over here, translator, or otherwise you can use the interface itself to capture it. So translator equals to new Italian translator, and then what you do, translator dot okay, the method is not there, it's my bad, I forgot to create the method in the interface. So we're going to just go over here and say void translate to Italian, right? Because obviously the method should be there when you are using parent reference over here, for example inside the client over here. So the parent p equals to new child we are doing. So during runtime, so what will happen is it will not be able to find the method which is translate to Italian in the parent, which is the translator interface. So that's why we are not able to find that particular method while we were writing before. So here if I try now translator dot translate to Italian, now you can see that the method is there. Now if I run this code, guys, so nothing is happening, because even though we have this method over here translate to Italian, we do not have any source, right? From where will we translate to Italian? So the source is the adaptee, right? Because we will take whatever this particular thing is saying. For example, instead of void, let us keep it string, right? And we're gonna return this. We're gonna say return arigato, right? So what is our requirement? Whatever the Japanese guy says or whatever this particular method returns, we're gonna take that and then translate it to Italian, right? I hope that is making sense. Now to do that, we need this particular method inside our adapter. Now obviously we cannot use any kind of inheritance or anything, because that doesn't make any sense. It will not work over here. But instead of that, we will have a has a relationship. So the adapter, in this case the translator, has a a reference to the Japanese guy. So it will have a has a relationship between the adapter and the adaptee, right? So what do I mean by that is, if we go inside the Italian translator over here, it will has a relationship. So you can have a what we say public Japanese guy, or you can make it private also. I mean, should be private. And over here you can create the object. So Japanese guy equals to new Japanese guy, and I'm gonna say string Japanese text equals to Japanese guy dot speak Japanese, right? And we're gonna have a very simple logic over here. We're gonna say if Japanese text dot equals arigato. Now let me see the text over here to say that that is arigato. So I'm going to just copy it from here and paste it over here. Okay, if Japanese dot equals arigato, we're going to return hello, right? Or else, yeah, this will also, let's also make this as string, right? Should be fine. It doesn't matter. Return. If it is something else, we're going to say invalid Japanese character, right? You can obviously improve this very feeble logic. I just want to explain like what is happening over here. So what is the problem over here? Okay, obviously, yeah, we need to change this to string. My bad. Okay, I hope that is fine. Okay, so here you can improve this thing and make a complete translator if you like, but over here I just wanted to keep things simple, so this is what it is. Now if I go back to the main thing, so here I would just say sout, I would say translator dot translate to Italian, and now if I run the code, guys, now if I say, you see it is translating to hello. So the source is the Japanese, which is saying the arigato. Then this translator takes the whatever the Japanese it is spoken and translates it to Italian. In this case I'm just writing plain English, but you are free to change it to Italian. And then this is the client, and this is how it works over here. So this is our adaptee, this is our adapter interface and the concrete adapter, and this is our client. So that's how adapter interface works, guys. I hope this was clear. If you have any doubts, please reach out to me in the comments, and in the next video series we are going to learn a new design pattern. Till then, have a nice day, bye bye, and take care.